Hello, and welcome to this journey through the peaceful wonders of our moon. Before we begin drifting through these calming facts, if you're enjoying this, please take a moment to like and subscribe to our channel. Also, we'd love to hear from you in the comments. Tell us what time it is where you are right now, and where in the world you're listening from. Now let yourself settle in. Find a comfortable position. Close your eyes if you'd like. Let's gently explore the serene mysteries of our closest neighbor in space. Our moon floats in the darkness of space at an average distance of about 8,850 miles from Earth. Picture that vast emptiness, that peaceful void between our planet and our satellite. If you were to take 30 Earths and line them up side by side, they would fit perfectly in that space. Such a simple comparison helps us understand the gentle separation between our world and this ancient companion. Imagine the moon's size compared to Earth. If our planet were a nickel, sitting there on a table, perfectly round and gleaming, our moon would be about the size of a coffee bean beside it. Such a gentle proportion. Not too large, not too small, just right for the dance these two celestial bodies perform together through the cosmos. Speaking of size, our moon measures about 2,159 miles across. To put this in perspective, it's roughly as wide as the entire United States. Picture driving from coast to coast across America, and you'd travel about the same distance as the moon's diameter. A journey of that magnitude frozen in a sphere, hanging silently in space. Every single day, the moon is moving away from us. Not quickly, not dramatically, just slowly and peacefully. Each year, it drifts about 1.5 inches farther into space. That's about 4 centimeters annually. Such a gradual departure, taking millions of years to create any noticeable change. In our lifetimes, and our children's lifetimes, and their children's lifetimes, the moon will appear essentially the same in our night sky. This slow recession happens because of the dance between Earth and Moon, the pull of tides and the exchange of energy between two bodies bound by gravity. Earth's rotation is gradually slowing, transferring that rotational energy to the moon, pushing it gently outward. It's a cosmic waltz that's been happening for billions of years. Our moon completes one orbit around Earth every 27.3 days. But because Earth is also moving around the sun, the time between full moons is slightly longer, about 29.5 days. This creates the lunar month, a cycle humans have used to measure time for thousands of years. Ancient calendars, religious observances, planting seasons, all have been guided by this gentle, reliable rhythm. Here's something peaceful to consider. Our moon is tidally locked with Earth. This means it rotates on its axis at exactly the same rate it orbits our planet. Because of this perfect synchronization, the same side of the moon always faces Earth. We never see the far side from our planet's surface. For billions of years, that hidden hemisphere has remained out of view, a mystery until spacecraft finally photographed it. People sometimes call it the dark side of the moon, but this is a gentle misconception. Both sides receive sunlight. When we see a new moon, the far side is actually fully illuminated. When we see a full moon, the far side is in darkness. It's not dark, just far, just hidden from our earthly perspective. The moon has no substantial atmosphere. What it does have is called an exosphere, a collection of scattered particles so sparse you could consider it essentially empty. Helium drifts there, along with argon, neon, and traces of ammonia and methane. Even sodium and potassium exist as gases in this thin envelope, but calling it an atmosphere would be generous. It's more like the faintest whisper of gas particles, barely present at all. Without an atmosphere to trap heat or moderate temperature, the moon experiences dramatic swings. In full sunshine, the surface reaches 127 degrees Celsius, well above the boiling point of water. But in darkness, temperatures plummet to -173 degrees Celsius. These extremes happen because there's no blanket of air to hold warmth or shield from cold. Yet despite these harsh conditions, water exists on the moon. Scientists discovered this relatively recently, and it changed our understanding of our satellite. Water ice hides in permanently shadowed craters near the poles. These regions never receive direct sunlight. Some haven't seen the sun in over 1 billion years. Inside these dark caverns, temperatures drop to -250 degrees Celsius. That's colder than Pluto. In these frozen refuges, water ice persists. Mixed with lunar dust and rock, these deposits could amount to hundreds of millions of tons. Some estimates suggest the ice could cover thousands of square miles, though distributed as tiny crystals throughout the soil rather than as solid sheets. Future astronauts might use this water for drinking, for creating breathable oxygen, even for rocket fuel. But water exists elsewhere on the Moon too. In 2020, scientists confirmed that water molecules exist even in sunlit areas of the lunar surface. Not puddles or lakes, but individual molecules of H2O, scattered and embedded in lunar dust grains. These areas are about 100 times drier than the Sahara Desert, yet water persists there somehow, defying expectations. How does water survive in sunlight on an airless world? Scientists are still working to understand this mystery. Perhaps the molecules hide in tiny pockets between grains. Perhaps they're constantly being created and destroyed in an ongoing cycle. The answer remains unclear, another gentle mystery waiting to be solved. Let's drift now to the surface itself. The Moon's face is covered in a fine powder called regolith. This isn't soil in the earthly sense. There's no organic matter, no decomposed plants or living organisms. It's pure mineral dust, created by billions of years of meteorite impacts and something called space weathering. Each impact pulverizes rock into ever finer particles. The result is a layer of dust that covers the entire surface. This dust is incredibly fine, finer than talcum powder. It sticks to everything. Astronauts during the Apollo missions found it clinging to their spacesuits, their equipment, even working its way into sealed compartments. One astronaut described it as smelling like spent gunpowder, though this comparison only makes sense to those who've experienced both. The lunar surface is marked by countless craters, tens of thousands of them, ranging from microscopic divots to vast basins hundreds of miles across. Each one tells a story of violent impact, of rock and ice slamming into the Moon at tremendous speeds. But viewed from Earth, through a telescope on a peaceful night, they create patterns and textures that humans have found beautiful for millennia. Many craters bear names of famous scientists and thinkers. Copernicus, named after the astronomer who placed the Sun at the center of the solar system. Tycho, named for Tycho Brahe, whose observations helped prove the motion of celestial bodies. Plato, Aristotle, Archimedes. The lunar surface has become a memorial to human knowledge and discovery. Some craters are simple, bowl-shaped depressions. These tend to be smaller, perhaps 6 to 9 miles across. They look smooth from orbit, like someone pressed a thumb into soft clay. Others are complex structures with terraced walls and central peaks. When a large enough asteroid strikes, the rebound of material creates a peak in the center, like the splash frozen in time from a droplet hitting water. Tycho crater is particularly striking, about 53 miles in diameter. It's located in the southern lunar highlands. But what makes Tycho distinctive are its rays. Bright streaks of ejected material radiate outward from the crater for hundreds of miles. These rays consist of material blasted from beneath the surface, exposed to space for the first time in eons. Fresh and bright, they haven't yet been darkened by radiation and micrometeorite impacts. When you look at the full Moon, those bright rays are visible even to the naked eye. Tycho looks like a bright star on the Moon's surface, with lines reaching out in all directions. It's estimated to be about 110 million years old, young by lunar standards. Another prominent crater is Copernicus, about 58 miles across. It sits on the northern edge of a dark plain. Its walls rise in terraces, and a complex central peak rises from its floor. Young enough to retain its sharp features, Copernicus is thought to be around 800 million years old. Then there's Giordano Bruno, a much younger crater on the far side. Scientists estimate it formed perhaps 10 million years ago, maybe less. Its walls are sharp and high. Material ejected during its formation hasn't yet been worn down by the steady rain of micrometeorites. It remains pristine, a fresh wound on ancient terrain. Let's talk about the dark areas you see when you look at the Moon. Ancient astronomers called them maria, the Latin word for seas. They thought these dark patches might be actual bodies of water. Mare Tranquillitatis, the Sea of Tranquility. Mare Serenitatis, the Sea of Serenity. Mare Imbrium, the Sea of Rains. Beautiful, peaceful names for what turned out to be ancient lava flows. Billions of years ago, the Moon was geologically active. Volcanoes erupted, pouring lava across the surface. This molten rock was darker than the surrounding highland material. When it cooled, it formed the smooth, dark plains we see today. The Moon's volcanic activity ceased about 1.2 billion years ago. Since then, it has been geologically quiet, a dormant world. The largest of these dark areas is Oceanus Procellarum, the Ocean of Storms. It stretches about 1,600 miles from north to south and covers roughly 1.5 million square miles. That's larger than the Mediterranean Sea. From Earth, it's the most prominent dark feature, visible even without a telescope. These Maria exist primarily on the near side of the Moon, the side facing Earth. The far side has relatively few dark planes. Scientists believe this asymmetry relates to the Moon's formation and the thickness of its crust. The near side has thinner crust, making it easier for lava to breach the surface billions of years ago. Speaking of formation, let's consider how the Moon came to exist. The most widely accepted theory involves a catastrophic collision. About 4.5 billion years ago, when Earth was still young and molten, a Mars-sized body struck our planet. This impactor, named Theia by scientists, hit with tremendous force. The collision vaporized rock from both bodies. Materials sprayed into orbit around Earth. Over time, this debris coalesced, gradually clumping together under its own gravity. Within perhaps 100 million years, the Moon had formed. Born from violence, yet appearing so peaceful in our sky. This origin story explains several mysteries. It explains why the Moon has a relatively small core compared to its size. It explains why Moon rocks have a similar isotopic composition to Earth rocks. It explains why the Moon lacks water and volatile elements, which would have been vaporized in the impact. Inside our Moon there's structure. A small iron core sits at the center, about 149 miles in radius. Around this core is a shell of liquid iron, about 56 miles thick. Then comes a partially molten layer, and finally the mantle, likely composed of minerals like olivine and pyroxene. The mantle extends up to the crust, the solid shell we see from Earth. The crust itself varies in thickness. On the near side, it averages about 30 miles thick. On the far side, it's thicker, perhaps 50 miles or more. This difference may explain why volcanic lava more easily reached the surface on the near side, creating those dark maria. The Moon's surface is ancient. Most of what we see dates back over 3 billion years. The highland regions, lighter in color, represent the Moon's original crust. They're heavily cratered, each impact a moment frozen in time. The maria are younger but still incredibly old by human standards. The youngest major features are just millions of years old. This ancient surface preserves a record of the solar system's history. Every crater, every ray, every subtle variation in color tells us something about the impacts that shaped not just the Moon, but the inner solar system. Earth experienced similar bombardment, but our active geology has erased most traces. The Moon, being geologically dead, keeps the record intact. Looking up at the Moon, you might notice it appears to wobble slightly over time. This phenomenon, called libration, allows us to see slightly more than half the lunar surface from Earth. In longitude, the Moon speeds up and slows down in its elliptical orbit, letting us peek around the eastern and western edges. In latitude, its tilted axis lets us see over the northern and southern poles at different times. Over many years of observation, these librations let us see about 59% of the Moon's surface. Not quite 60%, but close. That remaining 41% remained completely unknown until spacecraft could photograph it. The Moon's phases follow a predictable rhythm. New moon, when the Moon passes between Earth and Sun. Waxing crescent, as a sliver of light appears. First quarter, when half the disk is illuminated. Waxing gibbous as the lit portion grows. Full moon, when the entire near side reflects sunlight back to Earth. Then the reverse waning gibbous, last quarter waning crescent, back to new moon. Each phase lasts about 7 days, though this varies slightly because the Moon's orbit is elliptical. Sometimes it's closer to Earth, moving faster. Sometimes it's farther away, moving slower. These variations create slight irregularities in the timing of phases. When the Moon is closest to Earth, at a point called perigee, it's about 14% closer than at its farthest point, apogee. This difference means the Moon can appear up to 30% larger and brighter at perigee than at apogee. When a full moon occurs at perigee, people call it a supermoon. The term isn't scientific, but it captures the impressive sight of an unusually large, bright full moon. The Moon's gravity, though only 1/6 that of Earth, profoundly affects our planet. It's the primary driver of ocean tides. As the Moon orbits Earth, its gravitational pull creates bulges in Earth's oceans. Water on the side facing the Moon bulges toward it. Water on the opposite side also bulges, due to the way gravitational forces work across a spherical body. As Earth rotates beneath these bulges, we experience high and low tides. Most coastal areas see 2 high tides and 2 low tides each day. The Sun also contributes to tides, though less strongly than the Moon. When Sun and Moon align during new or full moon, their gravitational pulls combine to create especially high tides called spring tides. When they're at right angles during the quarter moons, we get smaller neap tides. This gravitational interaction does something else. It gradually slows Earth's rotation, very slowly. The length of our day increases by about 2.3 milliseconds per century. In the age of the dinosaurs, days were shorter. In the distant future, days will be longer. This is called tidal braking. The energy Earth loses through this slowing gets transferred to the Moon, which is why our satellite is gradually moving away. It's a beautiful exchange. Earth slows down and Moon speeds up, moving outward. This process has been happening for billions of years and will continue for billions more. The Moon may have played a crucial role in making Earth habitable for life. Its gravitational influence stabilizes Earth's axial tilt. Without the Moon, Earth's tilt would vary wildly over millions of years. This would cause dramatic climate shifts, making it harder for complex life to evolve. The Moon acts as a stabilizing anchor, keeping Earth's tilt relatively constant. Some scientists suggest that the presence of a large moon might be necessary for a planet to develop and maintain complex life. If this is true, then moons like ours might be rarer in the universe than we'd expect. The collision that created our moon might have been an unlikely event, making Earth-Moon systems special. Throughout human history, the Moon has inspired wonder and creativity. Ancient peoples tracked its phases to create calendars. Agricultural societies planted and harvested by lunar cycles. Religious ceremonies coincided with new moons or full moons. The Moon became embedded in human culture. Countless myths and legends feature the Moon. In many cultures, it's associated with femininity, night, mystery, and transformation. Werewolves transform under full moons in European folklore. The Chinese celebrate the Mid-Autumn Festival with mooncakes. Islamic calendar months begin with the sighting of the new crescent moon. The Moon permeates human experience. In modern times, the Moon represents achievement. When President Kennedy declared America would land a man on the Moon, he set an ambitious goal that seemed almost impossible. Yet on July 20, 1969, Neil Armstrong and Buzz Aldrin walked on the lunar surface while Michael Collins orbited above. One small step for man, one giant leap for mankind. 6 Apollo missions successfully landed on the Moon between 1969 and 1972. 12 astronauts walked on its surface. They collected rocks, conducted experiments, planted flags, took photographs. Then the visit stopped. For decades, no human returned, but interest in the Moon never faded. Robotic missions continued. Orbiters mapped the surface in incredible detail. Impact probes searched for water. Rovers explored the terrain. Countries that had never sent missions to the Moon joined the effort. India, China, Japan, Israel. Lunar exploration became truly international. Now new plans are forming. NASA's Artemis program aims to return humans to the Moon, this time establishing a sustainable presence. Other nations have similar ambitions. Private companies are developing lunar landers and rovers. The Moon is becoming accessible in ways that seemed impossible just decades ago. Future lunar bases might shelter in lava tubes, natural tunnels formed by ancient lava flows. These tubes offer protection from radiation, from meteorites, from temperature extremes. Some lunar lava tubes are enormous, potentially large enough to house entire cities. They exist just below the surface, waiting to be explored. Imagine living on the Moon. You'd weigh 1/6 of your Earth weight. Jumping would send you soaring upward. But moving in a bulky spacesuit would still require effort. The silence would be absolute. No wind, no rain, no animal sounds, just you and the machinery of your habitat. Looking up from the Moon, you'd see Earth hanging in the black sky. A blue and white marble, slowly rotating. Weather systems swirling across oceans. Continents drifting by. Earth never moves from its position in the lunar sky because the Moon is tidally locked. It would simply hang there, eternally present. The sun would cross the sky slowly. A lunar day lasts about 29.5 Earth days, 2 weeks of continuous daylight, then 2 weeks of darkness. Solar panels would need to store enormous amounts of energy to survive the long night. Or bases would need to be positioned where sunlight is more consistently available. At the lunar poles, some crater rims receive nearly constant sunlight. These peaks of eternal light could be ideal locations for solar-powered bases. Meanwhile, the permanently shadowed craters nearby would provide access to water ice. A lunar base could potentially have both power and water in close proximity. Mining the Moon might become economically viable. Certain rare earth elements exist in lunar soil. Helium-3, a potential fuel for future fusion reactors, is embedded in the surface. The Moon has no atmosphere to interfere with mining operations, no environment to protect. Some see this as an opportunity. Others worry about disturbing our nearest neighbor. For now, the Moon remains largely untouched, A few small areas bear the marks of human visitation, footprints in dust, preserved forever in the airless vacuum. Flags, now likely bleached white by unfiltered sunlight. Scientific equipment, some still functioning, some long silent, but most of the moon remains as it has been for billions of years. Serene, silent, ancient. A companion to Earth through deep time. Scientists study the moon to understand Earth's history. Moon rocks contain clues about the early solar system. The isotopes in these rocks help date events that shaped both worlds. The lack of an atmosphere means the lunar surface preserves ancient impacts that Earth's weather has long since erased. Some of the oldest known rocks come from the moon. Samples from the Apollo missions include crystals over 4 billion years old. These crystals formed in the moon's early magma ocean, floating to the surface as lighter minerals. They represent some of the oldest solid material in the Earth-Moon system. By studying these ancient rocks, scientists can reconstruct the conditions that existed when the moon was young. The moon was once molten, a sphere of liquid rock cooling slowly in space. As it cooled, different minerals crystallized at different temperatures, separating into layers. The lightest minerals formed the crust. Denser minerals sank toward the core. This process took tens of millions of years. Gradually, the moon solidified, its surface hardened. Volcanic activity continued for billions of years more, but eventually that too ceased. The moon became the quiet, inactive world we know today. Meteorite impacts continued throughout this time. Earth and Moon both experienced heavy bombardment early in their history. The rate of impacts has decreased dramatically over billions of years, but it never stops entirely. Even today, small meteorites strike the moon regularly. Monitoring programs watch for these impacts. When a meteorite hits, it creates a brief flash visible from Earth. The biggest recorded impact in recent years occurred in March 2013, creating a flash bright enough to see with the naked eye. The meteorite was estimated to weigh about 40 kilograms and was traveling at 90,000 kilometers per hour. Most impacts are far smaller. Micrometeorites constantly rain down, each one microscopic but collectively significant. Over millions of years, this constant bombardment pulverizes surface rock into finer and finer particles, creating and refreshing the regolith layer. This space weathering also affects the color and reflectivity of the surface. Fresh impact sites appear bright because they expose material that hasn't been darkened by radiation and tiny impacts. Over time, these bright areas fade, blending with the surrounding terrain. Only the youngest, freshest craters retain their brightness. Some features on the moon have acquired unofficial nicknames. Valentine Dome, a volcanic formation shaped like a heart. Thor's Hammer, a T-shaped ridge that resembles the mythical weapon. The Ghosts of Procellarum, remnants of ancient craters just barely visible beneath solidified lava. These informal names help observers locate and remember features, even if they're not officially recognized. The moon's mountains are impressive. The tallest peaks rise over 15,000 feet above their surroundings. The Montes Apenninus, a mountain range on the edge of Mare Imbrium, contains some of the highest peaks. The Leibniz Mountains near the South Pole may include even higher summits. Though their exact heights are difficult to measure, these mountains aren't like Earth's mountains. They weren't pushed up by plate tectonics. Instead, they're the rims of ancient impact basins, material thrust upward by tremendous collisions. The mountains around Mare Imbrium, for instance, are the rim of the Imbrium Basin, created by an impact billions of years ago. Some lunar features remain mysterious. Transient lunar phenomena, or TLPs, are brief flashes or glows that observers have reported for centuries. Most are probably tricks of light or viewing conditions, but some remain unexplained. Could they be gas releases from deep underground? Small impacts? We're not certain. There are also strange swirls of bright and dark material scattered across the surface. These magnetic swirls appear to be associated with magnetic anomalies in the crust. How they formed remains unclear. The moon has no global magnetic field today, but early in its history, it may have had one. These swirls might be remnants of that ancient field, rills or channels wind across the lunar surface. Some are collapsed lava tubes. Others might be grabens, valleys formed when the ground sinks between parallel cracks. Some rills stretch for hundreds of kilometers, meandering like rivers but formed by completely different processes. One of the most famous rills is Hadley Rill, visited by Apollo 15. It's a channel about a mile wide and more than 1,000 feet deep, winding across Mare Imbrium. The astronauts drove their lunar rover to its edge, peering down into the shadowed depths. The Apollo missions left behind equipment that still provides data today. Seismometers recorded moonquakes until they were turned off in the late 70s. These moonquakes reveal information about the moon's internal structure. Most are very small, but some occur regularly, triggered by tidal forces as Earth's gravity flexes the moon's interior. Reflectors placed by Apollo astronauts are still used today. Laser beams fired from Earth bounce off these reflectors, and the round trip time reveals the moon's distance with incredible precision. This is how we know the moon is receding at about 1.5 inches per year. These reflectors are simple devices, arrays of corner cube prisms that reflect light back exactly toward its source. They require no power, no maintenance. They've functioned perfectly for over 50 years. They may continue working for centuries or longer, silent witnesses to human achievement. The lunar module descent stages remain on the surface, along with lunar rovers from the later missions. Flags stand in the airless environment. Though exposed to unfiltered sunlight, they've likely been bleached white. Tools, cameras, and various pieces of equipment lie where astronauts left them. Footprints remain perfectly preserved, with no wind, no water, nothing to disturb them. These impressions could last millions of years. They're delicate but permanent, a reminder that humans once walked there. Recently, spacecraft have photographed these Apollo landing sites from orbit. The images show the descent stages, the trails where astronauts walked, even the tracks left by lunar rovers. These sites are now considered heritage sites, worthy of protection as the first places humanity stepped onto another world. Future visitors to the moon might tour these historic locations. Imagine standing next to the Eagle, the lunar module from Apollo 11, seeing the footprints, the flag, the plaque that reads, "Here men from the planet Earth first set foot upon the moon, July 1969 AD. We came in peace for all mankind." But beyond these few historical sites, the moon remains a frontier. Vast expanses have never been visited up close. The far side in particular remains largely mysterious. No human has ever seen the far side with their own eyes. No spacecraft has landed there to explore directly, though rovers may visit soon. China's Chang'e 4 mission did land on the far side in 2019, the first spacecraft to do so. Communication required a relay satellite positioned beyond the moon to send signals back to Earth. The mission included a small rover that explored the von Karaman crater in the South Pole, Aitken Basin. This basin is the largest, deepest, and oldest impact basin on the moon. About 1,600 miles across and 7.5 miles deep, it represents a catastrophic collision that occurred early in lunar history. The impact may have excavated material from the moon's mantle, providing scientists with insights into the moon's interior composition. Future missions may return samples from this basin. Studying mantle material could answer questions about the moon's formation and internal structure. Each new mission adds to our knowledge, slowly piecing together the story of our companion in space. Water on the moon could enable long-term human presence. If astronauts can extract and purify ice from permanently shadowed craters, they won't need to bring all their water from Earth. This significantly reduces the cost and complexity of lunar missions. Breaking water into hydrogen and oxygen provides breathable air and rocket fuel. Oxygen is particularly valuable. It makes up a large portion of rocket propellant mass. Producing it on the moon means spacecraft could refuel there, using the moon as a staging point for missions deeper into the solar system. This concept, using local resources rather than bringing everything from Earth, is called in situ resource utilization. It's key to making space exploration sustainable. The moon could become a proving ground for technologies that later enable missions to Mars and beyond. But we must balance exploration with preservation. The moon is scientifically valuable in its pristine state. Each footprint, each rover track, each piece of equipment left behind alters the environment slightly. As activity increases, the cumulative impact could be significant. Some argue for designating certain areas as lunar parks, protected from development. Others point out that the moon is vast, and humans will likely explore only a tiny fraction of it. The debate continues as plans for lunar bases and commercial activities advance. Legally, the moon belongs to no one. The Outer Space Treaty of 1967 established that celestial bodies cannot be claimed by any nation. They're the common heritage of humanity, but the treaty is vague about resource extraction and commercial activities. As interest in lunar resources grows, these legal questions become more pressing. For now, the moon remains peaceful. International cooperation in space has been remarkably successful. The International Space Station brings together nations that sometimes disagree on Earth. Perhaps the moon can continue this tradition, a place where humanity works together toward common goals. Looking at the moon from Earth, it's easy to forget the complexities. It appears as a simple, serene presence in our night sky, sometimes a sliver, sometimes full, sometimes hidden entirely. Its light is actually reflected sunlight, yet we call it moonlight as though the moon produces its own gentle glow. This light has guided travelers for thousands of years. Before electric lights, the full moon provided enough illumination to work or travel at night. Farmers called different full moons by different names. The harvest moon, occurring near the autumn equinox, rises at nearly the same time for several nights, providing extra hours of light for bringing in crops. Other full moons have names too: the wolf moon in January, the snow moon in February, the worm moon in March. These names vary by culture and region, but they all reflect humanity's close observation of lunar cycles. The moon affects more than tides. Some animals time their reproductive cycles by lunar phases. Certain corals release eggs and sperm simultaneously during specific moon phases. Some fish spawn according to tides. Even terrestrial animals may be influenced by moonlight, though the evidence is less clear. Humans have long believed the moon affects behavior. The word lunacy comes from luna, the Latin word for moon. People once thought the full moon caused madness or strange behavior. Modern studies have found little evidence for this, but the belief persists in popular culture. What's certain is that the moon affects human experience. A full moon rising over the ocean is beautiful. A crescent moon hanging in the twilight sky inspires contemplation. The moon's presence in our sky connects us to our ancestors who looked up at the same celestial body and wondered. They wondered what it was made of. They wondered if anyone lived there. They wondered if they'd ever reach it. For most of human history, these were idle speculations. The moon was unreachable, forever distant. Then, in the span of a single century, everything changed. Rockets powerful enough to escape Earth's gravity were developed. Computers capable of calculating trajectories were invented. Materials strong enough to withstand the harsh environment of space were created. And in July 1969, humans walked on another world. That achievement represents one of humanity's greatest accomplishments. Not just the technical prowess required, but the vision, the determination, the cooperation of thousands of people working toward a common goal. The moon landing showed what humans can achieve when we work together. Since then, our robots have explored the entire solar system. We've sent probes to every planet. We've landed on comets and asteroids. We've flown past Pluto and sent a craft into interstellar space, but only the moon has felt human footprints. Perhaps that will change in our lifetimes. Plans for returning to the moon are advancing. The Artemis program aims to land the first woman and first person of color on the lunar surface. International partnerships are forming. Commercial companies are developing lunar landers. The moon is entering a new era. After decades of relative quiet, it's becoming a hub of activity again. This time, the goal isn't just to visit but to stay, to build bases, to extract resources, to use the moon as a stepping stone for further exploration. Imagine a future where people live and work on the moon, where tourists can visit for a vacation, experiencing low gravity and seeing Earth from space, where scientists conduct research that's only possible in the lunar environment, where engineers test technologies for Mars missions. That future may arrive sooner than we expect. Technology advances rapidly. What seemed impossible yesterday becomes routine today. The moon, which once represented the limits of human ambition, may soon be just the beginning. But even as we plan to transform the moon into a destination, a resource, a home, it remains what it has always been: a companion to Earth, a light in our night sky, a source of wonder and inspiration. On clear nights, take a moment to look up. Find the moon in whatever phase it's displaying. Remember that you're looking at an actual place, a world with mountains and valleys, ancient lava flows and frozen water. A place where 12 humans have walked and many more may walk someday. Remember that the same moon has been there throughout human history. Ancient peoples looked up at that same scarred face. They created myths to explain it. They tracked its phases and used them to order their lives. The moon has been a constant presence as civilizations rose and fell, as languages evolved and changed, as humanity spread across the Earth. And the moon will remain long after we're gone, slowly drifting away, slowly changing, but essentially eternal on human timescales. Billions of years from now, when the sun begins to die, the moon will still be there, a silent witness to the solar system's end. For now, though, it's ours to study and explore. Each new discovery reveals something unexpected. The moon, despite decades of study, still holds mysteries. still surprises us, still teaches us things we didn't know about the early solar system, about planetary formation, about the processes that shaped our own world. It's humbling to think about. This object in our sky, this companion that has always been there, contains secrets about the very beginning of the Earth-Moon system, secrets we're only beginning to uncover. The moon reminds us of our place in the cosmos. We're not separate from space, from the universe. We're part of it. Earth is a planet orbiting a star, with a large moon orbiting Earth. We participate in these cosmic dances whether we realize it or not. Looking at the moon can provide perspective. Whatever troubles we face on Earth, whatever challenges occupy our minds, the moon continues its ancient orbit. The tide continues to rise and fall. The phases continue their cycle. There's something comforting in that constancy. Perhaps that's why so many people find the moon calming. It represents something beyond our daily concerns, yet connected to us. It's distant but visible, mysterious but familiar, ancient but ever present. As you drift towards sleep, imagine the moon silently orbiting Earth. Picture it floating through the darkness of space, reflecting sunlight back toward our planet. Think about the ancient craters on its surface, each one a frozen moment from billions of years ago. Consider the astronauts who walked there, how they bounced across the surface in 1/6 gravity, how they looked back at Earth, a blue marble in the black sky, how they felt knowing they were the first humans to stand on another world. Think about the future explorers who might return, people who will see things no human has seen before, who will venture into lava tubes and permanently shadowed craters, who will perhaps make the moon their home. All of this is real. Not science fiction, not fantasy, but actual possibility. The moon isn't just an object in the sky, it's a place, a destination, a world waiting to be explored. And it's there right now, at this very moment, continuing its ancient path around our planet. Whether you can see it or not, whether it's day or night where you are, the moon is there, constant, reliable, beautiful. Some nights it's bright enough to cast shadows. Some nights it's a thin crescent, barely visible. Some nights it's not visible at all, hidden between Earth and Sun. But it's always there, always present, always part of our cosmic family. Scientists continue studying it. Missions continue visiting it. Our understanding continues growing. Each year brings new discoveries, new insights, new appreciation for our nearest neighbor. Yet despite all we've learned, despite all we know, the moon retains its mystery. It remains something special. Not just a cold rock in space, but a companion that has shaped Earth's history and may shape humanity's future. Think about the phases of the moon. How the illuminated portion grows from nothing to a full circle, then diminishes back to nothing. This cycle has repeated billions of times. It will repeat billions more. It's both ancient and eternal. People have watched this cycle throughout history. They've celebrated full moons with festivals and ceremonies. They've used the cycles to mark time, to plant crops, to navigate seas. The moon has been part of human culture longer than recorded history. And perhaps that's the most remarkable thing. Despite all the changes humanity has experienced, despite all the technological advancement, despite going from stone tools to spacecraft, the moon remains fundamentally the same. We see what our ancestors saw. We wonder as they wondered. That connection across time is profound. When you look at the moon, you're participating in an experience humans have shared for hundreds of thousands of years. You're looking at something permanent in a world of change. So as you relax into sleep, know that the moon is there, orbiting Earth at its steady pace, reflecting sunlight, creating tides, stabilizing our planet's tilt, being a companion in the vastness of space. Rest easy knowing that some things endure, some things remain constant. The moon will rise tomorrow and the day after and the day after that. The cycle continues, as it has always continued, as it will continue long after we're gone. Sleep well, knowing you live on a planet blessed with such a companion. A planet where the night sky includes not just stars, but a world close enough to see with your naked eyes, close enough to reach in a few days' journey, close enough to study and understand. The moon is a reminder that we're part of something larger than ourselves, part of a cosmic dance that began billions of years ago and will continue for billions more. We're privileged to witness it, to study it, to occasionally visit it. And perhaps that's enough, to know the moon is there, to appreciate its beauty and its mysteries, to feel connected to both our past and our potential future through this one celestial body. Let your thoughts drift like the moon drifts through space, peacefully, quietly, following paths established long ago. There's no rush, no urgency, just the slow, steady movement of celestial bodies through the void. The moon teaches patience. It moves at its own pace, unaffected by human concerns. It doesn't hurry. It doesn't slow down. It simply continues, following the laws of physics, the pull of gravity, the momentum of billions of years. We can learn from that. Learn to move at our own pace. Learn to follow our own path. Learn that some things can't be rushed, shouldn't be rushed, and that there's beauty in steady progress. Each day the moon rises about 50 minutes later than the previous day. This gradual shift creates the relationship between moon phases and tides, between lunar cycles and natural rhythms. Nothing happens suddenly. Everything unfolds in its own time. Imagine you're standing on the moon, looking at Earth. You'd see your home planet hanging in the sky, never moving, always in the same position. You'd watch weather patterns swirl across oceans. You'd see lightning storms flicker in the darkness. You'd see city lights appear as Earth rotates. From that perspective, Earth would seem fragile, a thin shell of atmosphere protecting all life, oceans covering most of the surface, continents arranged in familiar patterns. Everything you know, everyone you've ever met, concentrated on that one beautiful world. Astronauts who've left Earth's orbit describe this view as life-changing, seeing our planet as a whole, floating in space with no visible borders or divisions. Just one world, one home for all humanity. The moon provides that perspective. It's far enough away to see Earth as a complete sphere, close enough to see details. It's the perfect vantage point for understanding our place in space. And from Earth, the moon provides perspective too. When life feels overwhelming, looking at the moon can help. It reminds us that we're part of something vast and ancient. Our problems, while real and important to us, are temporary in the grand scheme of things. The moon has seen civilizations rise and fall. It's watched species evolve and go extinct. It's been there through ice ages and warm periods, through asteroid impacts and volcanic eruptions. And through all of that, it's remained essentially unchanged. There's comfort in that permanence, in knowing that some things endure regardless of temporary troubles. The moon will be there tomorrow, next week, next year. It will be there for your children and their children. Perhaps future generations will look at the moon differently than we do. They might see it as a destination rather than just an object in the sky. They might know people who live there. They might visit it themselves. But even then, even when the moon becomes familiar, when humans have walked across large portions of its surface, it will still inspire wonder. Because no matter how well we know it, the moon represents achievement and possibility. It represents our ability to reach beyond our world. Every time humans look at the moon, they're reminded that we're capable of incredible things, that we can set seemingly impossible goals and achieve them. That distance and difficulty don't have to stop us. The moon is proof that dreams can become reality. For thousands of years, reaching the moon was impossible. Then it was theoretical. Then it was a goal. Then it happened. And it can happen again. What other impossibilities might become possible? What other dreams might humanity achieve? The moon suggests that the answer is anything, given enough time, effort, and determination. But for now, tonight, the moon is simply there, a light in the darkness, a companion in space, a source of gentle illumination and endless fascination. As you continue relaxing, imagine moonlight falling on various places around Earth. On oceans, creating a shimmering path across the water. On mountains, illuminating snowy peaks. On deserts, casting long shadows from dunes. On cities, adding its glow to streetlights. Moonlight is subtle. Unlike the harsh brightness of sun, moonlight is soft and gentle. It creates mood rather than just visibility. It transforms familiar landscapes into something slightly mysterious. Artists and poets have been inspired by moonlight for millennia. Songs have been written about it. Paintings have captured it. Stories have been set beneath it. There's something about moonlight that touches human emotion in ways sunlight doesn't. Perhaps it's because moonlight feels special. It's light that has already taken 8 minutes to travel from the sun to the moon, then another 1.3 seconds to reach Earth. It's light that has bounced off ancient lunar rock, carrying information about the moon's surface composition in its reflected spectrum. Or perhaps moonlight feels special because it only appears at night, when the world is quieter, when distractions fade and we have time to contemplate, when the darkness makes even modest light seem precious. Whatever the reason, moonlight has a quality that people have always appreciated. It provides enough light to see by without eliminating the mystery of night. It creates a balance between visibility and shadow that feels almost magical. On nights with a full moon, the landscape changes. Colors become muted but visible. Details emerge that darkness would hide. The world takes on a silvery quality, as though dusted with powder. Creatures that hide during the day emerge. Nocturnal animals hunt and forage. Owls swoop silently between trees. Bats navigate using echolocation. The night world comes alive under the moon's gaze. Even plants respond to moonlight. Some flowers open at night, releasing fragrance to attract moths and other pollinators. These night, blooming plants have evolved to take advantage of the moonlit hours. The moon influences Earth in ways we're still discovering. Its gravitational pull affects not just oceans but also the land itself. Earth's crust flexes slightly as the moon passes overhead. This Earth tide is much smaller than ocean tides, only about a foot in amplitude, but it's measurable. This constant flexing generates heat through friction. Deep inside Earth, rock moves in response to the moon's gravity, and this movement contributes to our planet's internal heat budget. It's a small contribution, but over billions of years, even small effects add up. The moon may have helped keep Earth's interior molten, maintaining the magnetic field that protects us from solar radiation. Without that magnetic field, Earth's atmosphere might have been stripped away by the solar wind, making life impossible. So the moon isn't just a pretty object in our sky. It's an essential component of the system that makes Earth habitable. It stabilizes our rotation. It creates tides that may have helped life transition from sea to land. It provides light at night. It generates poetry and art and wonder. Considering all of this, the moon represents one of the universe's happy accidents. The collision that created it could have destroyed both bodies. Instead, it resulted in a stable system that has persisted for over 4 billion years. What are the odds of that? What are the chances that two bodies would collide at just the right angle, with just the right speed to create a moon of such perfect size? Not so large that it destabilizes Earth's orbit, not so small that it lacks gravitational significance, just right. Scientists call this the Goldilocks principle. Everything about Earth seems to be just right for life. The right distance from the sun, the right size to hold an atmosphere, the right composition to have liquid water, and the right moon to stabilize everything. Perhaps such perfect conditions are common in the universe. Perhaps billions of Earth-like planets with Earth-like moons exist among the countless stars. Or perhaps we're rare, lucky beneficiaries of unlikely circumstances. We don't know yet. We've discovered thousands of planets orbiting other stars, but detecting moons around those planets remains extremely difficult. We can infer they probably exist, but confirming specific moons at interstellar distances challenges current technology. Someday we'll know more. Someday better telescopes will reveal the moons of distant planets. We'll discover whether systems like ours are common or rare, whether large moons are necessary for life or just helpful. But regardless of how common or rare we are, the moon is our companion. The only moon humans have ever seen up close. The only moon we've walked upon. The only moon that lights our nights and pulls our tides. And it's beautiful. Not despite its scars, but because of them. Each crater tells a story. Each dark plane represents ancient volcanism. Each bright ray radiates from a relatively recent impact. The moon's face is a history book, written in rock and dust. Reading that history requires skill and knowledge. Scientists can date different regions by counting craters. More craters mean an older surface, one exposed to impacts for longer. Fewer craters suggest younger terrain, perhaps covered by lava flows that erased earlier impacts. By combining crater counting with analysis of rock samples returned by Apollo missions, scientists have created a timeline of lunar history. They know when the major impact basins formed. They know when volcanic activity peaked and when it ended. They know how the moon evolved from a molten sphere to a cold, dead world. This history parallels Earth's early history, but while Earth's active geology has erased most evidence of that violent past, the moon preserves it. Studying the moon helps us understand our own planet's youth. Earth and moon formed together from the same collision. They share a history. Understanding one helps us understand the other. They're not separate worlds but partners, bound by gravity and origin. This partnership has existed longer than life on Earth. When the first simple cells emerged in ancient oceans, the moon was already old, already settled into its current orbit. When fish first ventured onto land, the moon was there. When dinosaurs ruled, the moon watched. When humans evolved and spread across the planet, the moon guided them. And the moon will remain long after humanity is gone. If we destroy ourselves, if we colonize the stars and leave Earth behind, if we evolve into something unrecognizable, the moon will continue orbiting. It doesn't need us. But we have needed it, and may continue to need it. Perhaps that's humbling. Realizing that this companion we've taken for granted is actually essential, that its stabilizing influence makes Earth habitable, that its presence shapes our planet in ways both obvious and subtle. We should appreciate the moon. Not worship it, but recognize its importance. Understand that we're fortunate to have such a large, nearby satellite. Realize that the moon is both common, a simple sphere of rock, and special, a companion that has enabled life on Earth. As you relax deeper into sleep, let these thoughts drift away. You don't need to hold on to them. Like the moon itself, they'll still be there when you wake. The knowledge, the wonder, the appreciation, all waiting for you. For now, just rest. Let the image of the moon hang in your mind's eye. Silver or gold, crescent or full, however you see it. Let it be a focal point for peace and calm. The moon doesn't rush. It doesn't worry. It doesn't stress about tomorrow. It simply exists, following its path, being what it is. You can be like that too. Letting go of worry, existing in the moment, following your natural rhythms. Sleep comes in its own time, like the phases of the moon. You can't force it. You can only create conditions for it to happen. Relaxation, darkness, quiet, comfort. These are the equivalents of the moon's orbit, the natural conditions that lead to rest. Let yourself sink into those conditions. Let your breathing slow to match the gentle pace of the moon crossing the sky. Let your thoughts become as quiet as the lunar surface. Let peace settle over you like moonlight on water. There's no hurry. The night is long enough. Sleep will come. Just as surely as the moon will rise tomorrow, sleep will arrive tonight. Trust in that. Relax into it. Think of how patient the moon has been. 4 billion years of orbiting Earth. Never stopping, never rushing, always maintaining its steady pace. You can be patient too. Patient with yourself, with the process of falling asleep, with the gentle transition from waking to dreaming. The moon doesn't judge itself for having craters. It doesn't worry about its scars. It simply is what it is, shaped by billions of years of history. You can be like that too. Accepting yourself, letting go of judgment, being at peace with who you are. Moonlight doesn't try to be sunlight. It's different, softer, subtler. It has its own quality, its own beauty. You don't need to be anything other than yourself. Your own pace, your own way, is perfect. As the moon follows its orbit, you can follow your path into sleep. Natural, easy, requiring no effort. Just release. Just let go. Just allow the natural process to unfold. Imagine floating in space beside the moon. Weightless, peaceful, silent. Nothing to do, nowhere to go. Just existing in the moment, in the vast quiet of space. That's how sleep should feel. Effortless. Natural. Like coming home. The moon has been home to 12 humans. Brief visits, but profound experiences. Those astronauts describe the peace they felt despite the hostile environment, the silence, the vast perspective, the feeling of being part of something larger than themselves. You can access that feeling too, that sense of peace and perspective. You don't need to go to the moon. You can find it right here, right now, in the quiet of night, in the comfort of rest. Let the moon be your guide. Its steady presence, its reliable cycles, its patient orbit. These are models for how to live, how to rest, how to be at peace. The moon doesn't fight against gravity. It works with it, using it to maintain orbit. You don't need to fight against sleep. Work with it. Let it support you. Let gravity pull you down into rest. Everything in the universe follows natural laws. Planets orbit stars, moons orbit planets, water flows downhill, and living beings need rest. It's not weakness, it's necessity. It's natural law. You're following that law right now, moving towards sleep, toward rest, toward restoration. Your body knows what to do. Your mind knows how to let go. Trust them. Trust the process. The moon trusts gravity. It doesn't worry about falling. It knows the forces that hold it in orbit are reliable. You can trust the forces that lead to sleep. They're reliable too. Billions of humans have fallen asleep before you. Billions will fall asleep after you. It's one of the most natural, most universal experiences. You're joining an ancient tradition, as old as life itself. Animals sleep. Birds sleep. Even insects have sleep-like states. Every living thing needs rest. You're no different. You're entitled to this rest. You deserve this peace. The moon deserves nothing. It simply receives what gravity and momentum provide. You deserve rest, but you also simply receive it. Let it come to you. Don't chase it. Don't force it. Just receive it. Like moonlight falling on your face. You don't reach up to grab it. You simply let it arrive. Let sleep arrive the same way. Gentle, natural, inevitable. The moon will be there when you wake. The stars will still shine. Earth will still turn. Everything will continue. You can rest knowing that the universe doesn't need you to hold it together. It's been managing for billions of years without your conscious oversight. Let that be freeing. Let that help you release control. The world will be fine while you sleep. Everything will still be here. You can safely let go. Drift now, like the moon drifts through space, peacefully, silently, beautifully. There's nowhere else you need to be, nothing else you need to do. This is your time, your moment, your rest. The moon has blessed Earth for billions of years with its presence. Let it bless you now with thoughts of peace and beauty. Let it guide you into deep, refreshing sleep. Let it be a companion on your journey from waking to dreaming. Sleep well under the moon's gentle